volt, ferro-resonant regulated, selenium rectified power supply.
Does it work off single phase or?
Yeah, single phase.
Oh, okay.
It's running on single phase 208. We have three phase
Oh,
wide.
208, yeah.
Yeah, 120 208 wide down here. But it's probably dissipating a couple hundred watts all the time.
Yeah, well, that's what we were talking
And
about.
our 24 volt DC load's about 2 amps.
Yeah.
So the efficiency is probably about 10%. And of course, a modern 24 volt supply would put out even 30 amps is about 3 rack units.
I always tell people, you know, they have these little bump in the wall power supplies. Oh, they don't use much power. Well, hold on to them. If they're warm, they're using power.
So how old is this? Because it says Western Electric.
Oh, well, everything
It's
here.
part of the gear that was donated to us in 1969 because it was obsolete.
Yeah.
So I think it was probably manufactured in the 50s.
Yeah, all of this Silicon stuff came up.
Yeah.
Yeah, I was involved in Led Sidley when I went down and talked to Pactel because they weren't happy.
Yeah.
Do you remember that?
Oh, I remember that.
Yeah.
Is Sam coming today?
I think so. I haven't seen him though on the Sam
I
Wood. Did you
eventually
see
got
his name
this-
on the list?
I think he was.
Yeah.
I eventually got the suspicion that his entire motivation in getting us this gear was for him to connect to Stanford and make free area phone calls. Because somehow, as soon as we got this thing running, the first priority was connected to Stanford, and the second was to run a line to your place, to connect your exchange to it. So, yeah, Sam could dial in here and make the Taiwan calls.
3 calls.
Where was your exchange?
Well, I lived just down the street in Hanover for a while, and then I moved to Menlo Park. I didn't have, I guess I had at least outside line, but I remember we
I'm
had
going to step out this way because the air conditioner.
the,
Heating myself.
my company merged with another company that had a roam, a big
Okay.
roam, and we had two three-phase chargers like that. Did you have set up batteries?
Okay, so Clint, do you want to explain the switchgear to him?
Well, yeah.
It's the line finders in that upper 2 bays.
Yeah. These.
The first selectors are on the back side.
Oh, okay. Each one of these connects with a.
100, yeah, the 100 level connectors at your knees,
Yeah.
and the 200 level connectors knee height back side.
Yeah. These are the line. These are the line relays. And each telephone line, this is all you get. You get 2 relays. Now, when you pick your phone up, there's 48 volts on the line, and it comes through one of these coils. This coil, I don't know which is which. This one has fewer contacts. But anyway, one of these, can I push one of them? It'll probably call a line finder.
The line relay will call a line finder.
Yeah. Okay. You
Cut off relays.
now think of statistics. These things, these are double. These can look for 200 people. You can only see 100, but these have 2 groups of banks. So but let's assume it's 100. So you're in a residential area, and you've got 100 houses. Well, anyway, these things, they put in only enough switches, let's say for 15 people talking at the same time. You know, you aren't using them. So what happens, you want dial tone. The only thing that is permanent with you are these 2 relays. This is the next guy and so forth. You get DC all the time out the phone line from the phone exchange. That's why when the power fails, you don't lose phone service. This, you close this, and one of these switches finds it. Well, we've gone it crazy. Well, one of the switches finds you and throws this relay. It takes the line finder effectively off, the line relay off, and gives you the first selector.
Why don't you pull off the 140?
Which one?
140.
Oh, here? No. 140.
Pull off the cover for 140.
Oh, here.
So pull off
Which one?
140 series.
This 100 and I don't 200. Oh, one no. Nobody's done it.
A4.
Oh, A4. Okay, he's gonna do it. All right. Well, what happens is that basically you get one relay that belongs to you. When you pick up the phone, it calls one of these to find you, and when it finds you, it basically closes one of these relays. It takes this off the line, and you're hooked to one of the first selectors. And the first selector, I forgot, is this a 3-digit system? But anyway, the first. No, okay, now it's pulled in. Let's see if we can. Oh, okay, here we are. Okay, so see that one's pulled in, but when he picked up, it pulled that one in. So once it found you, he's now hooked to the first selector, which is probably, yeah. Okay. So it lifted off. Huh. We'll go around the other side. John. Whoa. Yeah. See if we can get around here. Yeah. This is a first selector, so it only takes one digit. And I suppose it won't hurt any. We'll pick one of these up. A relay is the magic. You now are getting dial tone from this relay. Okay. And dial tone, but that's where you get the DC now for your loop, and it's balanced. There's 2 coils of 200 ohms each. So you got 400 ohms in series with 48 volts. Now you dial, and in dialing you open the line, ticket, ticket, ticket. Okay, so now I'm going to dial. I dialed 3, and it went up 3. And why it didn't find anything here? Maybe it's because we're not going to. But anyway, this has a possibility of 100. I'm sorry, 10. If we want somebody in the 300s group, this can find. It can find one of these out of 10. Big exchanges, you have more than 10 than these, what are called rotate. But anyway, so it gives you, in this case, it would be a connector. But anyway, in a big exchange, this only takes one digit. It'll hook to another selector that would take your next digit, and you work your way through the exchange. But the very last switch is a connector, and it takes 2 digits. You want to dial 45, say you call 345. You go 3 here, and it would find one of these on the 3rd level. Then you dial 4, and it goes up 4. You go 5, and it goes over 5. And that's where the telephone is connected. What we really need is a butt switch. Let's see if this is. Yeah. No, this is. Okay, this is a selector too. So I dialed 3, and it went and found somebody on the 3rd level. So these only take. And that level, they're all busy. So it went around, went all 10, and but how this system works, notice there are 3 wires. This is the tip and ring. That's your phone line, and these would be the line. And this is called the sleeve. Now, when you, this switch is sitting here, and the sleeve on this switch isn't grounded, but as soon as you pick up, it grounds the sleeve. You dial one of these switches, the next switch, and once this pulls in, it grounds the sleeve, and actually, you talk all the way through this to this. And the sleeve here, if this was your telephone number down here, If you're busy, your sleeve is grounded. So this comes around hunting on the sleeve. If it sees a ground, it gives you the busy tone. But if it isn't, it grounds it, which makes you busy to anybody else trying to call your same number. But the nice thing about this, let's see, this is a big exchange that has 7 digits. There'll be, the last 2 is here, so that's 5 more digits. There'll be 5 levels of these. So you got 6 switches hung up. When you hang up, the very last switch lets go of the sleeve, and every one of these drops at the same time. It doesn't go tuck, 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 tuck. It's a fabulous system.
Yeah, I like hearing that sound when they
Yeah.
open up.
But anyway, I don't know why. These must be other selectors. I don't know what. But anyway, you have statistics, and all of these people that come in here from those line finders, if they're dialing 3, or whatever, say the level is, then they have only 10 choices. And if it's a bigger exchange, they would, some of these would then, so this would look through number 1 through 10, and another group would look through 11 through 20 and so forth. So you spread out the statistics. But it's possible if everybody in this one group wants the same group of numbers, you could get it busy. But, anyway. But if this one, I'm not sure what number you dial here for. Used to be, you dial inside. But if you're dialing Stanford to get the Stanford switch, one of these levels looks for the trunks to Stanford. And it goes on into this. I have to find out what they're doing now.
I think 6 is for Stanford.
Okay, so it'd be 6. I'm not sure if I can dial 6 very well on here or not. I'm not doing very well. Can't get at it, but the A relay. We'll back up a little bit. How this sends dial pulses. You get dial tone, you pull this in. Okay, and there's do you know what a single pole double throw contact is? All right. Say we've got a contact and a relay, it pulls in. That's a single pole, single throw. But this has, when the relay is energized, it's touching that contact. When you pick it up, it touches that. Now we dial a number, and every time you dial, the dial opens the line, so the relay goes click, click, click. So we're going to dial a 3. It goes 1, 2, 3, like that, and that sends the pulse to the next switch. And the way it does it is this relay, there's a lot of other things I can't tell you what, but this relay will pull that relay in when it closes. That relay, you can't see it on this, but these are slow release. So while you open this one with little pulses, this one never moves. It will stay energized and routes the pulses down to these coils down here that, let's see where I can't get my finger in here, but anyway, one of them see this one here, the ratchets that drive that up, and then there's another set of coils that drives it that way. But the magic is what's called the A and the B relay. The fast relay that follows your dial pulses, and this one holds while you're dialing, and it manages to route the pulses. And once this switch gets the next switch, everything in this switch is pretty well disconnected. You come down, go through these 2 wires to the next switch, and the next switch comes back through this to hold this while you're talking, and it works its way through the whole system. But it really. Hello, Sam. Teeth on it. Well, as you go up, see these contacts here? This is not necessarily found on all switches, but as it goes up, notice it finds the hit thing. This can tell you, like, if you're in one mode and now it's going to go to a trunk mode. So when you've dialed 1, 2, 3, 4, 5, it doesn't do it. And when you get dial a 6, it knows you've got 6, 7, or 8. So it knows to do something different on those levels. Like it could be, it could be restriction and things like that. But this one, he's already been somebody's set it up.
Normal post springs.
Normal post. Well, these things had so many.
Hey, Clint.
Yeah. Hey. Yeah. This, see that thing that pulled in? Well, if you're up and this is stuck, that magnet will burn up. It draws so much current. But there's a contact that goes through every one of these and up to an alarm, and you get an alarm, and there's all sorts of things that are built in. All these banks, these are all wired in parallel. I don't think these don't have any grading, do they, on this around here?
Probably not.
Yeah.
This used to be a 3-digit system.
Yeah, that's what I was saying.
Where these would be probably the connectors here.
Well, I thought these were the first selectors.
Oh, these are
from
first
behind the.
Okay, but they have double. Normally, the first selectors don't have the. Anyway,
sort of thing.
maybe these are the connectors down here.
They look big enough. What it is that if this was the final thing where these were telephone numbers, then this one would be 1 1. 1 2 1 2, up 1 over 1 2 3. This next one up would be 2 1. The top one would be 0 0. Yeah. And if all of them are busy, the thing runs around. Let's see. I can't see the. But anyway, it runs around off the end and hits a thing that will either give you the busy signal or disconnect it. But this and this relay are basically the way that it routes the pulses. And when this switch is in use, that one will be on all the time. When these routes the pulses to some of these, which then decide whether it's going to be an up relay or the rotate. I can't get my finger in there. There's usually a.
I spent a lot of time wiring.
Oh, see there. That's called the normal. See that switch there? See that knows it's off, and when it came all the way down, this is trying to reset it right now. And when that came down to the bottom, then the reset went away. What you need is to get one of these out in the open somewhere where we can get a connector. Let's move on and see what. Well, these are transformers, but they're usually audio. So there's the one winding, there's 600 ohm impedance usually, and so there's something on the line on one side and the secondary is out. And like if you've got a circuit that you don't want grounded or you want it balanced, so audio goes through these. And they've got things like that. Ring back. Now, this is probably some magic trunk where you dial a number and hang up and it'll call you back. It's a test thing.
Test trunk.
A dial long line. What it is, the relay I showed you, that those are usually 200 and 200 ohms, 400 ohms with 48 volts. So that's, you can get 100 mils, but you've got 1,000 ohms of the phone wire. So the minimum for a 500 set is 23 milliamps. If the line's too long, you won't be able to pull that relay in. Well, a dial long line, you use occasionally, like you use some customer that's way out in the boonies. What this does in the phone exchange, everything is pretty much 48 volts, but you do have some other voltages, some for tubes, like there's 130 volts. And so what they do is they give you a relay for your long line, and it has, say, 130 volts on it and everything. Then it comes through and connects up, and then your audio path goes from this to the regular thing before you get the thing. So it's a way to provide service to somebody that's, too far away.
Does that replace local battery stuff?
Which?
Like local battery, when you have the sets with the local battery.
Oh, not necessarily. There is a thing called it's common battery signaling, local battery talk.
Okay.
And usually what that means, common battery signaling means the dial, there's enough current to make the dial work, but it isn't enough to make the micro.
Got it.
So you use it, it's like a phone. So the local battery runs your microphone.
Okay.
And those are, I don't think any of those are in the days way back, But and then if you're too far away, and the DC doesn't work, then there are things called repeaters. And I'm not sure, you must have some of them, but basically, here's a problem. You know what an amplifier is. You put a microphone in and it makes the signal stronger. Well, let's say we wanted to talk to somebody and we needed an amplifier, but you're gonna talk, and he's gonna talk. Now, how do you make the amplifier go the other direction? Well, one way is you could have like push to talk. I talk and then he has to push to talk, but that's not done. But if I hook the two amplifiers, the input from one to the output, that's a big circle, and it's going to howl at you. So there's a thing called a hybrid. It's a lot of fun. If you have a phone line that has a certain impedance, you can make a balanced circuit. It's got 4 points. You've got the phone line and the sending side and the receiving side.
So it
And you don't want this to come out here. So what it is, they make a network that looks exactly like you. It's so balanced that this signal goes that way and there isn't any going across.
Cancels out one side.
It's not perfect. See, you've got a phone line that is not a simple, it's not just a resistor. So therefore, you've got a lot of components and stuff, but that's how they make a repeater work, mostly for long distance.
Yes.
And then there's another problem with repeaters. All right, we've been talking about dialing. You pick your phone up, you dial, it's DC, and it goes through all the relays to here. Well, if we go to an amplifier, there isn't any DC paths. So now you've got audio amplifiers, two amplifiers, and what's called a hybrid. And then there's something else that detects your DC, and how you get it to the other end is done by manual. Let's say you're going to do it over a radio or a carrier. So instead of the DC, when you pick your phone up, say there's a tone. That's where this 2600 hertz, you've probably heard of it. That comes on. When you pick up, the 2600 hertz goes away, and the repeater at the other end detects the loss of that and connects the DC to the next switch. And then you dial and beep, 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 and all that. And so that's the way you can get long distance over radio or even on long phone lines where they do things. But today you go.
Okay, let me squeeze out of here.
You go into some digital thing. These aren't. Some of these are part of the key systems. Here are their key systems. You know how the key phones work.
You showed me a little bit. I know how they work.
With the little flashing light and that. Okay, well, basically, you got two wires coming from the phone company, and they come in, and the key system uses 3 pairs per line at your phone. First one is the line, and the next one is what's called the A lead. And so when you pick the phone up, you ground a wire that comes into this card, and this card does certain things, but you're connected to the phone line, and the third pair has the light on it. Okay, so somebody calls you, this detects the ringing. The ringing then puts the lamp flashing, and it keeps doing that until you pick up, and what's called the A lead, the one goes back. And so it takes lots of wires. But and if you want to put it on hold, what happens is you push the hold button. The hold button opens that A lead, but you're still drawing current from the phone line. So this says, he's on the line, but he opened the line, and it puts the hold on, which is nothing more than a resistor that looks like a phone to keep the, when you hang up, until you pick up and close the A relay again. And so each one of these is for one button on a phone.
What if you pick up from a different phone?
Oh, well, that if you've got, let's say you've got 5 lines, you've got 5 buttons on the phone, and everybody has the same line, then you'd have 5 of these. So every phone that picks up line 1, their A lead comes into here.
So is it 1 per line or 1 per telephone?
1 per telephone number, say.
Telephone number.
Yeah. Each button on the phone, you can have a lot of phones with the same lines on them. And anyone that has the same line uses the same card. And some systems, every phone has you could have 5 lines and 4 phones with the same 5 lines, or you could have one phone that had a different line, then you'd have to put one more of these in. And it's a nice system, and it's so great because you're in the phone. You open it up, and every one of the real lines is there. These electronic things, there's nothing in your phone. It all comes from the box when you say, I want it. But these things, like, so you got a phone, and you want to put an extra jack on line 3, you just go in there and find line 3 and bring the wire out. So but it takes those big gray 25 pair cables. There's three pairs per phone and 5, so that'd be 15 pairs. But then the ringer may be on a separate pair, and then they may have, you can do a heck of a lot.
It's a fat cord.
Yeah. And
what's the capacity of a system like this?
oh, okay. Each one of these switches. This is a connector, and this is a connector. There's 10 levels of 10 positions. And a connector, if this is the last one in the line, each one of those positions, the 2 wires, would be a separate phone line. Okay, so if I want to dial 35, this would go up 3, not 3, and then over. For some reason it won't go over. But anyway, it would go over to 5. 3, 5, and ring the thing. So relays on here, some of these have to do with ringing. It sends the ringing. When you pick up, it knows how to stop the ringing. And so, but your telephone will get all of its current from the A relay. And then now that's you can talk to 100 different phone numbers. Now this is reached by a selector, which you dial only one number. And let's say that the number we're talking about is 335. Okay. And these switches are on what are called on the 3rd level. So if I dial 3 on that switch, you'll find one of these, pull that in, and then you dial the last 2 digits. But let's say we got another set of levels. Let's say there's people called 4s. So you dial a 4 in that, and it would pick some switch out of a different level.
So one switch goes to a bunch of other switches.
Yeah.
That keep going on
And the normal old 7-digit exchange, the last switch hit 2 of the digits, so that's out of 7, we've got, that means it's 5, so there's 5 more switches. And each switch in a big exchange, the first digits come off of, you weren't here when he told about the line finder. Okay, the line finder, you can't afford to give a switch with dial tone to everybody. Let's say there's 100 people in your neighborhood. You can't have 100 switches. So you might have 10. Everybody, this is one customer. It's called a line and a cutoff relay. This is the next customer and the next customer. So when you pick your phone up, you're getting DC. You're getting DC from this relay. When you pick it up, it pulls the line finder in, and when the line finder finds you, it pulls this relay in and gets you into the system, which hooks to the first one of those switches in the chain. And that switch gives you the dial tone. And you dial 1 digit and you get to the next level and so forth. So now some tricks you can do with these. What happens, this gives you DC. And payphones in the old days would not give you dial tone unless you put money in. What they did is they opened one of the wires up, and you couldn't get a ground in the switch, and one of the wires comes through one of these contacts. But if you put a local ground, you can draw half the current through the relay and get dial tone. So this is some line that's set up what's called ground start, and that. But everybody has this. Now, what happens is you've got a lot of when you pull, you've got nothing on your line but this relay. Then when you get dial tone, this comes in and disconnects this relay and gives you dial tone on that switch. And as you work your way through the switches, but not only does it do that, this puts a ground. When your line is in use, this one is too, but there's what's called a sleeve, and the sleeve is grounded. And so the sleeve on this level for your phone number will have a ground. So the next guy dialing your same number, his switch comes around and does a test. One of these relays, if it sees a ground, whoops, I've got busy. Gives you busy. But also that sleeve holds every switch in the chain. It goes all the way through the chain and it comes back. And when you hang up, this one drops the sleeve and every one of them falls down at the same time.
But it's ready to take another call.
Yeah, and it's free. But this one, if you do that, that phone is high and dry now. There's no voltage or anything on it. And oops, turn it around. He's got some way to read the 30, 20, 30, 40. These are the numbers. But the connector he's got a lot more smarts in it than these. It has the ring trip relay, and it's got some other things. But the A relay follows your dial pulses, but when you pick up, it pulls in and it pulls the B in. But as you let go of it, the B doesn't drop. You notice? It's got a very slow release.
Yeah.
And that's how it routes the pulses down to make it
okay.
dial.
Pause.
Yeah, and that. Yeah. The system, there's a lot of. Then there's a lot. I don't know whether these 4 wires. You can do a lot of smarts. Like I said, if your line's busy, it gives you the busy signal. Now, if you're a big business and I have 10 lines, 31, 32, 33, 34, you can have a 4th bank. This actually has 4 wires. And by wiring it up, you dial 31, and this 4th thing says, wait a minute, it's busy. So it knows enough to kick the thing over to 32.
Really?
And so you can give people, multiple lines. So you say, oh, you only dial me at 31, but I've got phone numbers 31, 2, 3, 4, and 5.
It knows it can.
And now the only problem, it gets very complicated. Let's say you want more than 10 numbers. They've got switches. They've got a heck of a lot. It goes all the way around and says, whoops, oh, but there's some on the next level up. And then it sits there, and that gets beyond, too much.
They all have to be consecutive, though?
Yeah. That's the thing is they, on an electronic exchange, you could do pretty much anything. I mean, you can give them one number, but it has multiple accesses, but these things, the numbers have to be consecutive. But little more little toys. Let's see, where are the fuses around here? Oh, here. Okay. Let's say that something shorts out. So these probably, I don't know whether they have a fuse. These are fuses for maybe each switch. And something shorts in the switch. Okay, a fuse burns. But this thing, this one's probably burned out because it's out here. All right. It's like this. The fuse burns out, plunk, that little thing pops out.
It's there now.
But see, that's connected to that, and that, I don't know where he has it, but that pulls an alarm relay in. So the guy, and usually what it is a bunch of lights, and there's one for the row, and the one for a shelf, and stuff like that. So he gets his way down to about here, and then he only has to look at that latch. But, this is Bell system and telco. It's just, there's so many things you can do with the system that, and you can see these are multiple. Every one of these is all the same.
And I heard it took Phil almost more than 10 years to do all the wiring.
The thing is, they got these banks, let's see, that came, where are the terminals for these? These wires should all come out and go up, maybe, I don't recognize it, doesn't look right. But anyway, if all of these are wired together and come up to a terminal, they're all set. But if these aren't wired,
That's the. You should
I mean,
never have
I've
to
seen-
touch that.
Yeah, I have
What is
the
that?
one I have at home has a row of these that are these long, and I'm only using 4. I took the other ones and put a plastic bag and moved it around the back. I'm not going to cut it off. I mean, that's too much.
Once it's here, then you can.
Yeah, but now, if this was, he's got bank multiples. I have no idea what they are, but you would have one like this, and each. See, there's got to generally, well, this being line finders and stuff, this line finder can actually, instead of looking at 100, it can look at 200. There's 100 up here and another 100 here. Then this knows whether you're supposed to use the upper or the lower bank. So that means the people on this thing, instead of having access to 100 switches, they've got 200 available, which is a little more than. Or actually, what it is, let's say you're dialing, what do you say, 6 to get Stanford?
Yeah.
Then you only have 10 on 6. But there's another set of banks that gives you another, so you have more statistics. It helps.
So instead of 20 connection or 10 connections, the next one is 20.
Yeah. Well, see, there's 10 possibilities.
Yeah.
But if you had some of them on this and some this, then you could end up with the upper back will give you one set of 10 and the next another set of 10. And it gets very complicated. There's another thing called grading. Is every one of these, I'm sure, is the same. If you move over 3, you're going to get the same switch on the back always. So that means every one of these has a chance, 10 chances to get to that switch. But what happens, see these wires here? This wire will always be the same place on every one. But grading, where you have a very long shelf, this one sees 1 through 10, and this one sees, well, it'd be further down the line, would see 2 through 11, and 3 through 13, and so forth. So it spreads it out, but that's only in giant, central offices. But
So how many could this the capacity?
what?
Is
I mean, basically, these are line finders, and you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there's more line finders. These may be some. So this switch, at least 10 people could be talking at once.
Okay.
But the final selector, let's say that everybody's got a 300 number, and there's 100 in there, so that would be 100 people. But if they've got 3 numbers beginning with 3 and numbers before them, there's 200 people available. So this thing has the ability, how they've got it wired up.
There's a directory over on the wall.
Yeah, they see what their numbers are. But what would happen is one of these switches, one of the levels, I think he said was 6, will connect you over to Stanford switch. But then maybe 3 will connect you to these things here. But they could have 2 levels of selectors plus connectors, and each one of those is going to add 1,000 possibilities or something. Because you've got, so it gets bigger and bigger. But when you're talking about a few hundred people, it's this thing. The limit of how many can talk at once versus the number of people you have is
different.
You could have, like my switch at home, I have only possibility of 100 numbers, but I only have 2 line finders.
Okay.
So only 2 can talk at once. I actually have 3 connectors, but the one in the middle, the line finder in the middle, isn't a line finder. It has a trunk from this other switch. So I have a Mitel electronic switch. So if you dial 8 in that, you come over and get into my switch.
Does it go the other way too?
Yeah, let's see. How do I do it? Yeah. The problem is, of course, the Mitel is touch tone. Well, let's see. No, does it have rotary capability? Oh, that's right. The Mitel is smart. It's touch tone, but it will generate dial pulses. So I can dial from the MyTel to that, and then I can dial back. Yeah, like.
And then you can go back and forth and tie up all the lines.
But I only have one trunk. So, oh no, that was great fun, especially in places like England and small things. You look. You're supposed to be able to tell from this which one it is and which one it goes to. But if you're in a small town, let's say you're in a 3-digit town, and you got another little town over here. Well, to call that town, these you dial 7, and it gets you the phone over there. But if you're in that town, to call this town, you dial 5. So if you dial 7, 5, and I did this in England. I went back and forth about 6 times. Pretty soon the dial pulses can't follow, or and somewhere they'll run out of trunks. But that used to be the way. See, that's the fun of this system. You can play with digits. A modern electronic thing, you got to put 7 digits in before it does anything. So how do you know what happened? But in this, if I dial a 1 and it goes beep, 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 that doesn't mean anything. Yeah. I dial a 2, it doesn't mean anything. Dial a 3, oh, then I get one of these. Then I can dial other numbers. And so I know which, so it's very quick to find out which numbers are live and that. But, it's fun. What other things here
They have a tone to pulse converter on this one.
Oh,
so they
can
use touch tone phones.
Yeah, now, the way you would do a tone to pulse, and there are people, when there were so many of these exchanges when touchtone came out, there's a little box you can put on the back of these that's a tone to pulse for each one.
Doesn't it just go on, like, the line finders or the
it's on. Well, what it is, each line finder needs pulses. So if you get dial tone from this line finder, you'd have to have a tone to pulse converter on it if you were on a touchtone phone.
But you don't need it on the selectors then.
You don't need what?
You don't need it on the selectors, just the line finder.
Yeah, yeah. Because once you've gotten in here, that tone to pulse converter sends pulses to the rest of them, or should. Yeah. And those things can be smart too. You can program it not to dial certain numbers, or when they do that, and you can get a tone to pulse converter on your phone, which but that's not efficient on a switch.
And Mark said that they have to dial 6 star they have to dial star to shut off the touch tone converter after the dial 6. Otherwise, they'll have the dial pulses going and the touch tones.
Yeah, that. And if it won't take them, then
the Stanford PBX takes them.
Oh, that's right. It would be touch tone. Yeah. So
then you get the dial pulses and the touch tone.
Yeah. So those converters have some programmability. Got to switch there. Yeah. This. Whoops. So. You can't see that. That's the A relay. Mm-hmm. Wait a minute. Now that's strange. That's got a big copper slug. Usually it's the B relay. The A relay's got to follow the dial pulses.
Yeah.
And the B relay, that's not B relay. You don't want it to. And so the way to keep, when you put currents through the coil, it puts a magnetic field.
Keeps going for a little
and you
bit.
want something to keep the magnetic field going, and so there's a big copper slug around it that's a short circuit, and the current keeps it. But that one, that's got to be something special, because these didn't have that. What else we got?
He said these are the radio feeds.
Yeah, well, they got the FM transmitter up on the hill. They got to have lines up there. They also have lines all around campus too for remotes and things. And this, what are these?
Oh, these are telephone related, he said.
Yeah, this Maples is one of the gyms. Oh, okay. These are just repeat calls. Repeat calls are the same as these transformers here. Yeah. So when you bring a line, like you're going to do a remote broadcast, and so you've got your little amplifier in the field with the microphones coming in, and then it comes onto the line, and the line is a balanced line, and you would normally have a transformer talking, and then coming in here you put a repeat call transformer. But you understand what a balanced line is. All right, we've got a pair of wires going out in the booms, and you put a telephone on it. The audio current in the line is balanced, going one way or the other. Now, if we went out on one wire and came back through the ground or anything, or so we would get noise in one side of the line, it would add to our thing. Or if these lines going out and there's another line next to it, the signal in this line could transform in here. So what you do is you talk on a balanced pair that everything is equal on the side going out is coming back. So if you induce something across it, it cancels. So if you came in on a line from your remote and you had a ground, you had a horrible hum and stuff like that.
Okay.
So they're isolating every line for the repeat line before it goes into your studio amplifiers and stuff like that. What are these?
Voice conference bridge.
Oh, okay. These are just dumb repeat coils. You put something in on one side and you get the same thing out the other, but it isolates it. And these allow you to put multiple lines together. I mean, you can do that if it's local. You can tie all the lines together and everybody can hear each other, but it doesn't work if you get too many, and they may be able to put some gain in. So one guy on the way out here can hear him here, but he can't be heard going back. So these things
Balances everything out.
so it gets the levels and they make them receive equalization. That may have to do with the frequency response. Because your phone line's not going to be high-fi, but you can make it flatter, instead of losing the highs by adjusting somewhat.
Those are conference calls.
Yeah, but I think whether they're hooked up to any of this telephone or they're hooked up to for the broadcast audio, I have a feeling a lot of this is for the broadcast audio. There's a lot of stuff in the old days of broadcast that were related to telephone, balance lines, everything in the broadcast console was a balanced line, and most microphones. These are just simple amplifiers. Here. Paging trunk.
Oh yeah, you said if you dial 0, you're
Oh, okay.
on the.
Yeah, what this does, this can look like a phone line to the phone switch. When you dial into it, answers, and then you talk through this, and they can hook your speaker amplifiers on it. This is a conference trunk.
So do you know how that test phone back here works?
That
So
one?
that was wired directly to the selectors.
Oh,
Or something.
oh, okay. Well, I remember you go through the line relays and everything, and you finally get the A relay and the selector. Well, if you hook straight on the A relay without those relays, until that cutoff relay pulls in, the line finder won't be selected, there won't be anything on it. So if you do that, you wire each one of those buttons as a pair goes straight to the input to the A relay. I think that's probably what he's done. Then you'll get the dial tone from that relay, and you're in that switch without ever having to do anything. I guess it's more for a test purpose. Or,
So you can kind of use it like a button set, or
I don't. I mean, it'd be a way to go down the row and see if they're all working and things like that. I mean, you can specifically pick a selector which one you want. Here, when you pull the line relay, you don't know which one you're going to do. Whichever next one's available. So you have to find out whether. I mean, those.
I think it's labeled.
Label fix.
Yeah. A lot of these could be for the key systems. The usual, I said, each key system has 3 pairs, the
Yeah.
trip and ring of the one, and A lead and ground, and the lamp, and then line 2, and so forth. And it's,
And then each phone will come down here just like
yeah,
that.
well, see the gray cable. Well, this is some other kind of thing, but where you see these kind of cables, this will take 25 pairs Now this is a 50. See that these connections and these connections is 25 pairs or 50 connections, another 50 here. So they're only using half of that block, and one of those gray cables will tie down there.
I see. It all splits.
Yeah. But these are newer. These are the lightning arresters and things like that usually. And I think that's we got. Should have how they work. That's one kind of lightning arrestor. The line goes through that, and there's a heavy ground in there, and then there's something that breaks down if too much voltage. And there's 4 pins. The line comes in and goes out. If you pull that out, it just opens the line up. So if you want to test the line, you probably can get a test equipment with a plug just like that, so you can get all that switch off the line.
Okay, I see.
But now there's some repeat coils of an older type, a better type, and then those are probably audio transformers, but they're like microphone transformers and things with the same idea. Different metal. I mean, the big deal in telephone is balanced lines. There'd be 4, 2, and 2. They've got 2 windings like this, and you usually hook them in series, but you put a capacitor in the middle, and then there won't be any DC flowing. Mm-hmm. And then the other side, there's a lot of old tricks. The phone is, for example, you've got an open wire. This is in the old days. You put an open wire up, you get 2 wires. That's one pair. You got another 2 wires, another one. Now, how many wires you got? Got 4?
Yeah.
Well, I could tie a common to here in line 1, line 2, line 3, but the crosstalk and everything is bad. So this is a balanced line, and this is a balanced line. You take one of those transformers and hook it in the middle of another transformer. Well, the coils go out. You can get a third line going down the middle of the other 2 that's balanced.
Oh, you add an extra on the common.
But you don't get something for nothing. You still got to take 4 wires, but you get 3 balanced lines instead of 2 or 1. And I mean, dates way back in the days before electronics and amplifiers and things. And that's called a phantom. Or you can do another thing. You've got 2 audio lines, and you got the center tap of each. You can put a telegraph key on it, and the clicks from the telegraph won't go into the lines because they're balanced. You have to be a little careful. But you can now get a telegraph circuit over 2 voice circuits that are running.
Most information, least number of wires.
You know, there's a thing that you might, it's available. I'll send it to you. It's a wonderful, wonderful thing. It's put out in 1953, AT&T. It's basically a textbook for telephone thing that starts out with
Principles of...
It's a green book.
Yep.
Have you got that?
I have a PDF of it. I started
Yeah, I've
reading
got
it
the
once.
PDF. I have the original one. In fact, when I was just about out of college, I went and visited my uncle, who was a accountant with a telephone company in Virginia, and he gave me that book, and it is a Bible because it starts out simple, but then it shows you these hybrids and it shows you amplifiers and things, and it's much easier to see a book than the PDF. But you start looking at some of them, but you'll find how the transmission and balanced lines, and that's not important. Wonder where the rest of them are. Oh, what's happening? 8450, the gray, and the black stuff is all 8450. I think the stranded is 8451, right? Uh-oh. Got a fail.
Does it just stop after a few iterations?
It should go continuously, so something's broken. That's busied out. That's busied out.
I don't ever really see
There's CO trucks of his own device. I mean, this is not a...
What phones do you plug them in?
I have mostly 500 sets and a couple touch tones, and I have a 302,
Nice.
and then a couple modern phones that are basically garbage. So, yeah,
I have a lot of those.
those aren't any good.
Let's see. Let's see if I have any pictures. I have like...
Yeah, I made some videos of all of mine and put them online too.
Yeah. Just 2 more colors till I finish my 500 colors.
How many do you have? Oh yeah, way more than me.
So like the nicer, almost set. Got your, let's see, blue, Mediterranean blue, a rose beige,
Oh,
dark
you're
brown.
green. I wanted one of that. It was too expensive on eBay.
All these are soft plastic, is my goal. Except for like some of these weird colors, like gold, orange, turquoise. And then I have a couple, I like, sorry.
motor driven no. Yeah, I have one of those. Okay. From Woodbury Telephone. Woodbury Telephone. There's the converters. When I lived there. Oh yeah. Okay. So these are M164s or M168s, okay? Yes.
Yeah, my Mitel, I have an SF100, and it's similar to the program also.
So that's the standard ringing machine.
Yeah.
This.
What is this?
This is the ringing machine that would
Oh, I see.
normally provide dial tone, but he's got precise dial tone on here.
Oh, he does?
Yeah, if you pick
It's
it
not
up,
the old one?
you'll hear precise dial tone. Pick up
Oh,
the
that's
phone,
too bad.
you'll hear precise dial tone.
Yeah, too bad.
Yeah, I like the older one.
This is a DISA.
Oh, why?
A DISA, direct
Oh.
inward service access unit that takes a password to get through.
Did it say the number for it?
Teltone M106. I have the documentation for these.
No, I mean the number to call in.
Oh, it's not marked, but
So the M106s are inward dial.
yes. What's at home done? What is at home done? A Stanford public number? Yeah. So you can call into it and get dial tone off the switch, I assume, and dial within the
Yes.
facility. Yeah. Okay.
Secret number. It's got an access code
Oh, okay.
and a secret number.
Do you use it then?
Use it.
Our old transmitter remote control is dial up on the PBX. So I mostly would use this to call it.
What's the story on these CO trucks? These are CO trucks that you built that are compatible with the CDH?
Yes.
They work into the CDH?
Yes.
And KSD is KSU's own drawing
Yes.
designation?
Yes. I designed these things Christmas vacation 1970 and then tweaked the
Yeah.
design a bit.
Yep.
So they have inward dial and they also have trip off hold. So you answer incoming call, the call director put it on hold. You can
So
find
there's
one is on hold. I can pick up an extension, dial 31 and answer it.
so there's effectively, so they're like auxiliary trunks as the phone company.
Yeah, no auxiliary trunks.
Right,
Yeah.
yeah, we talked about this.
Yeah.
And so they include the support features for the pickup key on the call director. That's all integrated into it.
Pickup key.
The line key that you use on the call director to answer the call and put it on hold so you can dial in. All of that is integrated into the circuit. Isn't that?
Well, the way it works is if you put it on hold of the call director kind of the conventional way,
Yes.
then you can dial into the code like 31323334 following 1234 and answer it from any extension. The other thing is for inward calls, on the call director I can press the flash button and I'll get a KZSU dial tone
Oh, the
and I
flash
can
button
dial
does
an
it.
extension at the call director and then hang out the call director. I'd rather the call to the extension.
Right. I didn't understand the
A
business
feature
of...
that basically no one ever uses.
Right. I didn't understand what you were saying about calling into it with those 3-digit numbers or 4-digit numbers after it was conventionally put on hold. I didn't understand.
Oh, okay. There's a selector level interface.
Mm-hmm.
So if line 1 is on hold,
Mm-hmm. Oh, a call pickup function.
it's a call pickup.
Yes, if the line is on hold, it
On
could
hold
be...
or ringing, you can dial in
Yes,
and,
yes,
and pick it
okay,
up.
okay, got it. With a,
And then if you
with a
do
unique code
hook
for each
switch
phone.
flash, you can put it back on hold.
So that assumes that you've called the person and told them that there's a call
There's
for
a
you on.
paging, there's a selector level paging trunk. So you pick up an extension dial 0 and you're on the speaker.
Yep,
You say, Mark Lawrence, line 2,
yep,
and leave it on hold, and I can pick up an extension dial 32 and answer it.
yep.
So there's a single line phone in the toilet with a set of indicators for the status of line 1, 2, 3, 4, so you can answer a incoming call from the bathroom.
Yep.
Is this an eviscerated interrupter or what?
That is a modern interrupter. Yeah, it's a more
Well, it's a low
more
profile.
compact mode. It's a low
Oh,
profile
yeah, with a
motor.
horizontal shaft this way.
Right.
But I don't remember seeing them with a long cover like that.
Same size as a regular hitter.
Yeah, interesting. I guess that's
Yep.
so you can reach it and get it out. Otherwise, it would be hard to get it out with a card here. You wouldn't
Yep.
be able to grab it.
And then to run the interrupter motors off 24 volts DC, there's a inverter here whose cover is off,
You know, there's
and it has failed, reverting it back to a 10 volt AC transformer, which is why this is a 10 volt fail alarm.
you know,
It failed last year, and I said I'm not going to bother repairing it, because repairing it requires unwire wrapping a bunch of stuff and pulling it out of the wrap. But,
you know that there's a 24 volt DC version of all of these interrupters.
right, but we couldn't get it.
Yes.
You know, I
and,
mean-
and you know what it has inside? Inverter. It has an inverter inside, and it drives the 10 volt AC motor.
Right.
Because 10 volts AC is about 24 volts peak to peak.
Yeah,
So with a
so
couple
just
of
jumps it.
transistors, you know, you
Yeah.
can turn 24 volts DC into 10 volts AC.
Yeah, well, that's what this thing did.
Not a
is-
sine wave, but that doesn't make it matter.
Yeah,
so.
Right. You know, so that's you know, I've got a circuit for it. I designed and built this
Yep.
thing, you know, in like the early 70s, and
Yep.
it basically ran for 45 years or so. And then, you know, okay,
Pretty good.
I could fix it, but at this point, it's not on my priority list,
I hear you.
because the other thing was, of course, in the 70s we built this stuff. This building had no emergency power, so our batteries were the emergency power.
Mm-hmm.
So you look back there on the wall to the left, and then voting supply, it's the original emergency power controller. We have this 40 volt inverter. It's like 1.2 kVA. And we had, you know, the 100 amp hour 48 volt battery in the back room. And so when power failed, I could start the inverter and switch the critical circuits over to the inverter outputs. So that was our emergency power for the studios. And so we distributed the 24 and 40 volt power all over all the studios and stuff. So most of our vital stuff runs on plus 24 or minus 48, because it was uninterruptible power in the days before, you know, said affordable UPSs.
I've never seen KTU labels this color. Is this something you guys did?
No, probably faded or.
No. I mean, how could this fade to that? Doesn't seem possible. I've never seen that.
Well, I didn't do anything to change the color.
Okay, I've never
So
seen
I
that.
cannot
And
account
there's
for the
another
color.
one. Yes, I mean, I've seen hundreds of 400D cards, and I've never seen one with that color label.
Well, send me a reminder and I'll give you a couple of these when I pull this
That's
out.
very strange.
Does that on have the emergency power because of the auditorium and
Yeah, well, there's another whole long story about that, okay? Because when, in the early days, Memod emergency lighting was the big bank of plastic jar, lead acid, liquid electrolyte batteries, 120 volts worth at 200 amp hour. And the, you know, like exit lights and stairwell lights ran on circuits from there. So there was a transfer switch to transfer the critical lighting circuits to the battery bank. So emergency lighting was 120 volts DC. And then there was also a relay in the house dimmer panel that would drop selected house lights to the emergency bus when power to the house lighting panel failed. And on a power failure, those lights in total would be pulling about 80 amps on that battery bank. So some bunch of bright guys in facilities somewhere decided to replace it with something more modern back in probably the 70s or early 80s. But they didn't bother talking to either the electric shop or me or the drama department tech guy. Basically the three folks who could have told them how this thing really worked. And so some outside engineers came in and looked at it and said, okay, it looks like the load on this thing's about 40 amps. So they ripped it all out and put in these cabinets with batteries and inverters in them. And the first I knew about this project was our emergency power lighting circuit failed. And I go to discover the problem was it was all torn apart. They said they hadn't bothered to tell me. And I looked at it.
Where was this stuff located?
Far side of the building. Okay. In the basement.
Heat going out.
So, I called a bit and found out what was going on. I said, well, the thing is seriously undersized because it looks like you've only got 40 amps of capacity. And they said, well, yeah, we looked at it and that was the load. I said, yeah, but did you dump power to the house lighting panels so that the house lights would transfer? What? He said, well, we're going to test it. I said, okay, you test it. I give it 3/4 of a second. So yeah, they tested it. It lasted about 3/4 of a second before it went down. Now we had a problem. An auditorium with no emergency lighting. So the fire marshal said, you cannot have a public assembly in that building without emergency lighting. So they had a generator set outside, and every time there was something in them odd, they had an electrician standing by the generator to start it in case of a power failure, and paying double time to sit there and read a book.
At IBW rates.
Yeah. Well, it's not IBEW, it's Stanford employees, but they had a union too. So they rebuilt it with more capacity and got it, squeaking by. And then finally they decided to do it right, which is to say put in a generator, and also which is to say they talked to the drama tech guy and me about what we needed. And I said, well, emergency lighting, is about so much, but really we'd like about 5 kW extra capacity to run our critical circuits. Because our backup power was 100 amp hour, 48 volt storage battery running an inverter, which was enough to keep the studios on the air for a couple hours. So they put in a nice generator set with capacity. I ran a conduit over there and put in a 40 amp 3-phase circuit to a panel here. Emergency lighting panel, and so we put in now have a lot of generator circuits. So the emergency lighting, of course, is now AC, which lets you use fluorescent and use 1/5 the power, which is nice when you're running on backup power. And so at this point we have basically a whole separate panel, a separate wire color code, and orange outlets for the emergency, the generator back circuits. And everything critical's on UPS. So those UPS at the bottom of the beige rack are running the studios, and that's distributed through the switches on the back wall, which is basically a repurposing of the old inverter controller. The inverter's been junked long ago, because once those 40 volt batteries lost capacity, it was no longer usable anyway. And that panel is now repurposed to be transfer external power. They've got a couple of inlets by the back door where you could plug in a generator if you had to keep the really critical stuff running. And I did have to redo the feeder to that panel about 10 or 15 years ago, because as we got all these computers, they suck a lot of power. I need a lot of power to keep the computers up. And at one point we got this rack full of Suns, which would cause me to downsize switch frames so we could
make room for the rack of suns, when I realized we had neither enough power nor enough cooling in this room to run it. So it sat in engineering for a couple of years. And I learned why they call them suns. They put out a lot of heat. So they had their own UPSs sitting in the rack that we put in there. And one day I'm sitting at my desk and I hear a relay clicking on and off, and I poke around and realize that one of these UPSs is dropping the battery periodically because the line voltage feeding it is 108 volts. And I realized, okay, I've got this panel I put in with a view toward running, you know, a kilowatt of lights and 2 kilowatts of studio, and it's now powering all these suns and other computers. And it's number 8 wire running 150 feet, and actually to make it worse, this feed is from the old battery room, which is like just off the lower shop, but when they put in the generator, moved the control panel to the mechanical room. So basically this feed ran all the way to the old battery room and then back 45 or 50 feet to the, you know, so it's now like 200 feet of number 8 wire, plus the number 12 wire from their engineering. So I did the math and said, well, I can see why we got a voltage drop problem. So I had to run a new 1 1/4 inch conduit all the way through the basement, straight to the mechanical room, of course, to cut out the extra length. Because that cuts out, you know, 2x the extra length. And like number 1 wire, so we solved the voltage drop problem.
Mark,
Yeah.
will we be able to test the paging trunk or not?
Yeah.
Where's the precise dial tone supply? I didn't see that.
It is hiding under the patch cord.
Hiding under.
Oh, this?
Oh, yeah, there it is. Okay.
Builders and
Not one that I've seen before.
Yep. Built it in like 1970 or so, and I had a failure of it about 5-10 years ago. I had to replace a couple of transistors and a few other parts, you know, rebuild it. And it's still running.
I mean, only for ringing.
Yes.
Ring back tone, of course.
Yes.
Selectors.
And no mechanical work has been done on that thing in 25 years. So, you know, it's a miracle that the bearings haven't seized up.
Yes. Well, I've seen.
does it run all the time?
I've seen.
No, only when.
I've seen wear off.
Yeah.
I've seen wear on the interrupter cams where they self-destructed from lack of lubrication. The bearings were okay, but the interrupter cam wore down to the point it wouldn't turn the gear on the interrupter cam. Wore down.
Okay.
I sold a guy a machine like that. He took it to a machinist and had a gear made. And was able to resurrect it. And then he lived in New Orleans and he got wiped out by a hurricane. His whole place got flooded.
It's
submerged and
all
sold.
underwater. Yeah.
I had one
The
of those.
selectors are on this side?
Yeah.
Yeah.
Well, yes, yeah. The one's back there. I had a ringing machine I got at Buckley's.
Oh, good old Buckley's.
Good old Buckley's. And it worked, but something must have had shorted turns or something. It drew, you know, like 4 times the current. And
So this little panel down here is a regulator to produce minus 24 volts from the minus 48 volt battery on the key telephone here. It's just a linear
regular minus
circuit.
24.
Where is the tone to pulse converter? Is that here? It's just that?
So are there 3 of them?
Yeah, 2 trunks apiece.
Oh, I see there. 2 pieces. That's all tone.
And so this stuff, these are wideband repeat coils used on the various remote lines. And then there's a few that aren't wideband that I got, you know,
basically freebies from salvage, and I've got a couple of them in use on rented lines where I don't have wideband anyway. And Telabs is out of business, so these things are now pretty much extinct.
Yeah,
And occasionally I keep my eye open. I'd love to get some more 4425s.
Yeah, I look for these on eBay. I've never found any. I have a bunch of the 4008 program amplifiers, which are program grade program amps, but I don't have any of the coils.
Yeah, I got a couple other equalizers up at the transmitter on the analog line, and I've got some of my lines use 111Cs.
Yeah, I got a bunch of those too.
That's God's own repeat coil,
Oh yeah,
flat from DC to daylight.
amazing. Yes. I've heard of people using them as ring-through repeat coils when they ring through them.
Wow, yeah.
They apparently won't saturate at 90 volts, 20 hertz,
Yeah,
which is kind of amazing too.
yeah.
I mean, not to say that they didn't make repeat coils that were not broadband that did that. They did, but I wouldn't have expected those things to handle that.
Yeah. So my fiber coming in, main network switch. We've got a couple others. Actually, too many switches in here. I'm gonna try and shrink the number. I had some computing volunteers a few years ago decided we need like a switch in every rack, and I think fewer switches. The fewer switches, the better, because everyone's a possible failure point. I should probably just get another modern, like 48 port switch and cascade it off of this, and I could ditch this guy.
Yeah, my ringing, which I built a long time ago, is one of these green. It's a mill repeat coil. It's not a 111, but it's a military one, ring through.
Yeah.
And I chop it with a military 19 hertz vibrator.
You're talking about a C161. It's the green one.
Green. Yeah.
With the lugs on the mounting side, the 111C, the terminals are on top. The C161 mounts through the plate. It's
It mounts through the plate.
It's a phantom coil.
Yeah.
Pairs of them were used for phantom
One
circuits.
of the early things I built. It's a DC metering and for the 48 and 24 volt. So it's got hand-wound meter shunts on the back. And measure the voltage and current on both systems. And then I said I have the 24 volt main, 48 volt main for the switchgear, and a separate one for the inverter, which of course is no longer used. I know the inverter's been junk. But this was originally the inverter control. And besides the circuitry to start the inverter and switch over the output, it had an overload protector that would do load shedding. So each studio, we've got a two-pole breaker that's one side current and one side relay trip. And so if it's overloaded, it'll dump the least important load, which then with a Form C contact transfers the command to the next less important load. And it'll dump, eventually could dump everything except the studio that's on the air. So that's gone, that's discontinued too, because we no longer have to be that parsimonious with power. So yeah, those are the inverters that run the studios, and their power is distributed here. So each of the rooms has a double pole, double throw center off switch, so I can disconnect it
one way
or set it to inverter A1 and inverter 2. I mean UPS 1 or UPS 2. Originally, those were wired up to switch between the emergency power panel here and just a regular circuit. But the idea was at one point I realized I couldn't work on any red outlet circuit without taking us off the air because they were all together. So I put in the disconnects.
Cisco, that's all.
So that's the 48 volt distribution. Oh, and there's another funny story here. So we've got a meter on here to monitor the 48 volt battery voltage originally. And this, of course, is turned off because it runs on a battery. But we had a triplet 630, a nice 6-inch mirrored scale meter, sitting here on its 60 volt scale. At the time, I did not have this resistor. So, sometime in the 80s, Mikhail Gorbachev came to speak in
Oh,
Memoir.
I was onto that.
Okay, well, so they kicked us out of the building for the occasion, and we had to run from the transmitter site. So they did their bomb sweep, and it turns out the cops see a multimeter, they think it might be a bomb, but they decide if they can run the switch through all its positions, it must be okay. I don't know the logic of this. So they do a check through here. I didn't see him touch the meter, but I'm just about to close the doors. They're about to throw me out, and I see a fuse alarm. And I see the ringing machine fuse is blown. And that's the one the meter was clipped to. And I look at the meter, and the meter is seriously deranged. It's now on the 30 volt scale, and its pointer looks bent. And that fuse is blown. So I disconnect the meter and replace the fuse and get out of here. I come back and look at it. The meter is fried. And clearly what this idiot pig did was grab it while it's in the circuit and run the switch through its ranges. Well, of course, it's a volt-ohm milliamp meter. When you switch it to the 100 microamp scale across the 48 volt battery bank, unpleasant things happen inside the meter case. So it fried the meter and blew the ringing machine fuse. I still have that meter in the back room, my collection of electrical disasters. So the change I made was I decided the meter could run off resistance battery and still give me an accurate indication and not be quite so vulnerable.
Not gonna hurt it. What are these? Memory servers, and you got
Streaming and stuff. And this is network attack storage, which is backup for some of the Mac. So it's time machine backup for most of the Macs in the
the
station.
Mac, time machine work.
Yeah, it actually has nothing to do with these.
Garlic Pendleton, okay. That's your UPS. I've got a good UPS. What is it? It's like KVA or so. My company was building vans for the International Telecommunications Union required these third world countries to get their act together in keeping the frequency, like the FCC does. And so we made vans with antennas and things like that, and they had a UPS. And the UPS, it's a sine wave UPS. And they were running it, and every time the generator would like surge, UPS would go off, and then 5 minutes later it'd come back on, and then another surge, and they just totally ran the batteries down. They couldn't stand it, so they threw them all out, and I got one. It works fine. That's one of the things I probably need new batteries in, because it runs 3 or 4 6-volt batteries.
Good to meet you. Nice to meet you. Thank you for showing us. This was fantastic.
Back to Davis, eh?
Well, I'll be in town for another month. For something small, like what are you gonna sell? eBay $10, $15.
I hear you. That's my excuse too.
It's not actually on the air yet. It's just practicing.
What are these 3 standard DECOs used for? Or are they?
These?
Yeah,
They're not in service.
Okay. Because that's your standard one-way outgoing trunk.
Yeah. Actually, there's one of them in service because one of the CDHs died. Because we were using those CDH connected things for both incoming and outgoing.
Yes.
So there's one outgoing only line that's connected to the first of those CO trunks.
Well, I have a box full of CDHs if you want to solve
Sorry?
it. I said I have a box full of CDHs if you want to solve that problem.
Okay.
So if you need to restore it to service,
Well, I'm actually going to take a couple of those lines out of service soon. So
Okay.
probably don't need it
I'm
anymore.
offering you the option.
Okay, thanks.
I think I had to make my own Selectron.
Well, a nice little switch.
So Mark, if we dial 0, will we be able to hear the paging in here?
It's pretty noisy. Let's go into my office or the newsroom.
Oh, so you're not using the low tone off the ringing machine for anything, really?
No.
No.
Let's try it in here.
Shop. It does get quieter.
It's about 40 dB quieter in here.
Record.
This is a paging test. This is only a test. Thank you. That worked.
Heard it click.
Probably need to crank up the gain a little.
That's all that. Looks like a.
So how do you associate an input with an output reading these flashing LEDs? It seems to be a rather
Well, the input is associated with the output that's flashing, and to complete the connection, you press the take button.
okay, so what are the ones that are steadily lit?
Those are ones that are connected, but it's not obvious which one's connected to what.
That's what I meant. It seems like if they
I think if you press the take button now, those two should quit flashing. That's one of the yellow buttons on the left.
Take.
it seems like at the expense of much more rack space, if they had laid it out as a matrix with inputs on one axis and outputs on the other, it would have been intuitive.
Yeah, it ended up being, there's actually another box down below that's really got the guts of it in it. And that button thing is like an add-on accessory from the manufacturer, because they sort of said you could program certain combinations of routing. It's really kind of like a routing switcher thing. And I ended up not being real happy with it because of the complexity.
User interface.
The user interface is not good, and the cost is pretty high per input or output.
Yep.
And so yeah, trying to replicate what we have in the other room with one of that would have probably cost us $5,000 20 years ago.
And it's stereo audio, 600 ohm balanced, or
Yep.
what is it?
Yep. And of course, it's all kind of active circuits through there, which gives you some isolation and other features you don't get with the other patch bay. But it's kind of redundant now, because originally I said there were 2 racks there, a couple of real tape recorders. There's UPI audio, cassette deck, cartridge tape recorder. So now I guess there's a cassette deck and a DAT, and I don't know if either one is actually functional at this point. But all the recording is done on the Mac in the booth, and the Mac, the little console in the booth has a USB codec built in, so it's wired straight into the computer. And there's the demo of no dial tone. Oh, there we are. Oh no, it's 131. That's what I want. So there's ringing.
Hello.
Hello. Okay, let me put you on hold here.
All right.
There's hold. So we demonstrate hold, line in use.
Okay.
Okay.
Call back again.
Thank you. Have a nice day.
So you don't actually hear any bells ringing when you call.
Well, it depends on how you've wired it up. The way the key system works is you have a matrix that's on the wall there behind some of that stuff. It's a diode matrix, and so you have a matrix that says which lines should ring which phones. So the bell on the phone is connected to a position on the matrix, where I say, this phone should ring on 118 and 131, for example. So you get a diode from each one to make that work.
It's called common audible signal. It allows
Yeah.
you to have one
Common
bell,
ringing.
one ringer in a phone that operates
Yeah.
for any or all lines.
Right.
But then it won't work when the power goes out.
Oh, that's true, but there are power failure transfer relay units, KTUs, that will transfer the ringer to a specific line, so that when the power goes out, you'll be able to at least, have a ringer on the first line, so that you know that there are
Yeah,
incoming
got-
calls.
I've got the 1A2 system in my house. The whole house has got 25 pair cable. And I had a repeater where the line came in and then was amplified. I was telling you had to amplify both directions and have hybrids. And it worked very fine until caller ID came out, and I was too lazy. So when the repeater's in the circuit, the caller ID doesn't go through because the repeater came on when you picked the phone up. And so I just patched around the repeater, and now I can put caller ID things right on the phones. I'm too lazy to fix.
Okay.
Well, you could put a bypass relay that operates
Well-
on the first ring and releases
Yeah,
on
well,
the second. because-
actually, I have a power failure on my line, and if there's a power failure, it drops the repeater out and everything, and I've got to figure out. I can use that to drop the repeater out, but I have
Yeah.
to figure out what.
Well, the common audible control lead on the KTU
Yeah.
has a provision to deliver ground
Uh,
or steady ringing or
So,
interrupted ringing. So if you strap it to provide ground, then you can,
yeah.
you can make something operate or happen
Yeah.
when a call comes in on the line.
Yeah.
So you could
Yeah.
use that to release
Yeah.
to bypass the repeater.
Yeah. I've got,
Because then as soon as the call is answered, that ringing lead is going to go
yeah,
open.
that and then
and
put the
it will
repeater back in.
put the repeater
There'd
back
be a
in.
clunk going on at least, but yeah,
well,
it'd probably work.
I mean, the
Yeah.
receiver isn't to your ear yet when that happens.
Yeah.
So,
So can you get these phones to ring on internal calls, or is it just incoming external calls?
Whatever you want.
What's your extension
Like
here?
by default.
118.
I'll dial you.
you don't have an intercom system in the sense of a intercom system on the key system.
No, just the fact that you can call any room from any other room.
Right, because it's behind the PBX.
Yeah, so there's no. I don't think we have a ringer hooked up on this
Did you
phone.
get ringing on that?
No,
Yeah.
I don't think this ringer's even hooked up because you don't expect to be really taking a lot of incoming calls in this room.
Not in the studio, no, you wouldn't normally want that.
But other phones do have ringers hooked up then?
Most of them, yeah. Like in Studio A, the ringer's actually in the terminal cabinet.
A day of
And actually, I had a problem when
noise.
I put in the nice new voice over IP system because it doesn't have a bell as a contact closure when a line is ringing, but then no provision for sending intermittent ringing. And eventually, I kludged up a little relay that's hanging on the wall of the switch room to basically trigger the old line 3 is ringing lead from the old system, since line 3 doesn't exist anymore for incoming because that's the CDH that failed. So it actually makes line 3 ring, and then I disconnected the light for line 3 so people wouldn't get confused by a flashing light on a line they couldn't actually answer. But then I found that people were hearing the ringer over there by the old phone, so they assumed it was the old phone that was ringing. And they look over there and not see any lights and give up and not answer the new phone that's right there. So I had to send out a reminder to the staff last week to say, that ringer in Studio A is for old or new phone. Just look for the flashing light, people.
And look for the light.
So I need to devise a new ringer control circuit to use with the new phone. I bought a new
But it delivers
electronic ringer. and I
delivers a ground to you, you say?
Hmm?
When a VoIP call comes in, it delivers a ground?
gives you contact closure.
Gives you
Yeah.
contact closure. Well, you got an interrupter in the key system panel. You could,
Well, so effectively I'm making use of it now by kludging into the old line 3
Yeah.
connection.
yeah, okay.
But if I'm going to scrap that key equipment, then I will need to devise
True.
a new interruption circuit.
Well,
And I was starting to throw something together with a 555 timer, but
You could put a sound alert in. That would annoy them enough to answer quickly.
yeah, I thought I could just make it ring steadily, but I think that would be too annoying because you are trying to run a radio studio.
No,
in
yeah,
there.
you want interrupted ring, certainly.
So how do you avoid the ringing being heard on the air then?
There's a relay that goes in when the mic's turned on that cuts out phone bells, paging speaker,
Yeah.
stuff like that. and also lights up on the air light. And the mic arms now have little red lights in them to tell that
the
mic
mic
is
is
live.
And on the air light.
Yeah, so I've been converting to these nice new Yellowtech mic arms with
Yeah,
the
they are
internal
nice.
springs and the clamp knobs at the joints and
Yep.
and the little red on the air lights. They're very nice. They're
What do they cost?
outrageously expensive, but
How much they cost?
the mic arms are anywhere from about $300 to $400, depending on the size, plus the mounting, and so yeah. And then of course you need a controller to make the light work. I built a controller for in here, and I built a controller for Studio A. But before I got to Studio B, I found that Henry Engineering was making a controller that would handle two mics. So B Control now has a little Henry Engineering mic alert to control its lights. And
What impedance are you using the mics? XLRs with
yeah, they're
250 ohm or
nominal 250 ohm.
250
Yeah.
ohm. I have it's a 633, but it's not an Altec, it's a Western Electric 633 mic, the old salt shaker.
You know what a Western 639 is?
Is that the
It's
big fat
it's
one?
the big fat thing with a
Oh.
dynamic element and a ribbon and a switch on the back
Wow.
that mixes the two
Cardiac
elements.
or-
So you can get a circular pattern, you can get a cardioid pattern, you can get a figure 8 pattern, depending on which elements are
I'm not
active
sure if it
by turning the switch on the back with a screw.
belonged to
I
KZSU.
need one of these arms for that.
Yeah.
I have one that I picked up in an antique shop in Vermont for $5. Perfectly good. Walked into the
I want an
antique shop
RCA
and
44.
it called out to me from
Diamond.
across the space.
Yeah.
KZSU phone.
Yeah, that's my business.
Is this,
I mean, they
Mark?
Sounders.
this has got a 725 7-digit number on it. Is that?
That's engineering. That's my phone.
Uh-huh. So
Yeah,
it's
Stanford
it's
Centrex line.
right. That's what I thought. Yep.
So that's not hooked up to the switch?
That's not hooked up to the switch, but that trim line over there is.
Okay. I'm wondering what number I could call that wouldn't bother anybody.
Well, I called 145
What is that?
because this is 146.
Oh, okay.
So I just figured, I'll call the next number because at least I'll know it's valid. I don't know who it is, but
And this has a movable finger stop, it looks
it
like.
does.
Oh, and that's a built-in switch hook then.
This is the flash button
Oh, okay.
hanging up and using call waving and stuff like that without going back to the cradle.
Yeah, even the modern trim lines in our dorm don't have that.
Well, then they're not trim lines. All trim lines have a touch tone
Well, trim line light, but
dial and handset phone. So I wonder, given the fact that somewhere it said dial 6*9 for an outside line, how one does that on a
well, you
rotary
just dial 6. The star is to shut off the touch tone converter. So you just need to dial 6 to rotary phone. Do you hear another dial tone? Okay.
And then what's the 9 gonna do?
9 is outside PSTN then.
Oh, so the 6 goes into the Stanford switch and the 9 goes out to the PSDN.
Yeah.
I see. Yes, and there's dial tone immediately.
And then you should still have dial tone, I guess. So when you're dialing, I hear the bells over there.
That's interesting. Wow. I don't think you
Yeah,
heard.
whenever you
I don't
dial-
think you heard a bell. I think you heard a relay repeating the dial pulses.
I feel like it was a bell over there. If you dial a digit. Yeah, there you go.
You're right. Oh, that must be bridged. And the bell is tapping because the polarity is wrong. Okay. That's weird.
Does it work?
It works. Have you tried dialing out from here?
No, what did you do now?
I dialed one of my DID numbers.
Oh, yeah.
And listen to what happens. I dial 6 to get into the Stanford PBX. I dial 9 to get into the PSTN.
Yeah.
I dial my 7-digit DID number.
Yeah.
And I get a burst of precise ringback tone
The secret is
from the Stanford switch. I don't know why. Hey, Mark. See, that's an array of rows and columns. You put diodes in diagonally. You see the diagonal lines?
Mm-hmm.
That's to tell you how to rip the diodes. What do you do with gates? Yeah, I guess you can call it. I've got a military short military clerk switch to the. And what's in the KSU cabinet here? What's in this KSU cabinet? These are C161s.
Oh, yeah, no, it's not that kind.
Right, it's the green metal
green
case
is
one that
almost
mounts
the
on a
same
plate.
shade.
Yes, but I don't remember the number. I have one of those. It's electrically identical to this, but it's in a different format. It's
Yeah.
identical
Oh,
electrically.
I actually have one of those somewhere too.
I have one also.
With the binding posts.
Right. Yeah, it's C something else. It's a military coil and it's C something, but it's not C161. That's C161.
So if I dial 6, I should be able to just dial that extension then.
Yeah, in principle, yeah.
That's
54867.
4867.
54867.
What do you hear?
Oh,
It took long enough to complete, didn't it?
what?
It sure took long enough to complete, didn't it?
Yeah, it took a while. Usually calls go in pretty quickly.
I think Mark answered too. Yes, he did. We were making a test call.
Oh, are we on a 3-way call now?
Mark is on the line here in the other room.
Oh yeah, I hear him now.
No dials on anything. It's a Kellogg ICT. I mean, it's unusual in having a 1 to 0 plate.
Yeah, no letters.
That's normally used only for PAX service.
This one is.
That's on 146. That's why we heard the bell tapping.
This one, it's 145 as well.
Well, that's true, but if the bell was tapping, we got to lock up markers.